Greetings students, once again welcome to another lesson from iCampSA. In this lesson we're gonna be doing part 2 of the introduction to trigonometry, and it's mathematics, traits and mathematics. This lesson is aligned with the CAPS curriculum, and also yes, the DPE and IEP likewise. Okay, without wasting any more time, let's get into it. Okay, so we have already introduced the trigonometric ratios. So from here we're gonna be dealing with special angles. So we have three special angles that we're gonna cover in grade 10, and that is 30 degrees, 45 degrees, and 60 degrees. As you can see highlighted there, those are the three special angles we're gonna be covering in grade 10. So we do have other special angles, your 0, 90 degrees, 180, 270, also those are special angles, but in grade 10 we're only gonna be focusing in these three special angles, which is 30 degrees, 45 degrees, and 60 degrees. And what makes these angles special? So these three angles are special because we can determine the trigonometric ratios for these three angles without using a calculator. As you can see in the statement there below, the trigonometric ratios of special angles can be determined without using a calculator. Remember that so far when we have a given angles, let's say maybe angle 22 degrees, and we want to find the sine of that trigonometric ratio, we're just gonna go ahead and punch it in the calculator and say sine 22, and then we'll find the answer normally with decimal places. But with the special angles, we can determine the trigonometric ratios for the special angles without using a calculator. And how do we go about doing that? So we have two triangles that we use in order to determine the trigonometric ratios for the special angles without using a calculator. We have triangle A that you see there. So triangle A, the way that you're gonna see it, or is the way that you're gonna see it, is that it has the angles of 45 degrees. So both of these triangles are actually right-angled triangles. So for this one triangle, we're going to be focusing on one half of the triangle, so it's an equilateral triangle. But let's start with triangle A. With triangle A, it's a right angle triangle with the angles 45 degrees. So it's a right angle triangle, but it's also an isosceles triangle because we have equal angles there, and the 90 degrees angle Okay, so and another thing for triangle A is that the sides of triangle A are gonna be what? Are gonna be 1 and 1, and then that other side, the hypotenuse side, we essentially calculated it by using the Pythagoras theorem. So if you remember the Pythagoras theorem, when we calculate the hypotenuse side, we're gonna say c squared is equal to our side, that other side is what is 1 squared plus that other side, which is also 1, and then we solve for c, which is our hypotenuse side. 1 squared is 1, 1 squared is 1, so 1 plus 1 is 2, and then we introduce a square root on both sides. Therefore c is going to be root 2. It's going to be root 2, of which is what we have there, that is how we actually got that root 2 there. So we construct a triangle with angles which are equal to 45 degrees and sides which are equal to just 1 unit. That's the first triangle that we're gonna use in order to determine the trigonometric ratios for the special angle of 45 degrees. As you can see that the angles within the triangle about 45 and 45 degrees. Okay, and then for triangle number B, what you do, you simply construct and what is this triangle called? It's an isosceles triangle. Sorry, it's not an isosceles triangle, it's an equilateral triangle because it has all the sides are equal. So you construct an equilateral triangle, all the three sides are equal, two units, as you can see there. And also side CP there is also 2 units, just that we then go ahead and then draw a line from point A perpendicular to line CP, perpendicular to line CP, that dotted line that you see there, so when we draw a perpendicular line from point A, or a line from point A, from point A perpendicular to line CP, that line will bisect line CP. That's how the equilateral triangles work. It will bisect it. That means it will separate it into 2 equal halves. As you can see, we have 1 unit, which is CD. It's just 1 unit, and we also have DP, which is also 1 unit. So this is an equilateral triangle. 1 plus 1 is 2. This side is 2, this side is 2, and this side is 2. And the angles that we're gonna have in this equilateral triangle, so all the angles must be equal within an equilateral triangle. As you can see, we have 60 degrees here, we have 60 degrees, and then here also this angle will be bisected. 30 plus 30 is 60 degrees, and then if we draw a line perpendicular to side CP, that line will also bisect the angle, and hence why we now have what? We have 80 degrees on both sides. We have 30 degrees on both sides. Okay, and then we left with what? We have side CD. Let's focus on one triangle. This one here, maybe let me just highlight it. Let me just highlight this one. This triangle I want us to focus on, and the angles within that triangle. We have that 60 degrees angle and that 30 degrees angle on that yellow triangle that I've highlighted. And remember that we have side CD, we have side CD, which is 1 unit, and we have side CA, of which is opposite to the 90 degrees, which is also equal to 2, and also is a hypotenuse side. So since we have these 2 sides, we can also calculate side AD by still using the Pythagoras theorem. Just that right now side AD is gonna be the subject. So we can quickly do that just to show how do we get that √3 here. So we're gonna have AD, the side we are looking for, squared, is equal to the hypotenuse side 2 squared minus the other side, which is 1 squared. So we have 2 squared, which is 4, minus 1. We have 2 squared, which is 4 minus 1. Therefore this is equal to 3. 80 squared is equal to 3. We introduce a square root on both sides. This will make AD to be equal to √3. That is how we actually got that √3 that you see there of that other side, Hopefully that makes sense. Okay, and then we now have the other 2 special angles, which is angle 30 and angle 60 degrees. We have the other 2 angles, which is angle 30 and angle 60 degrees. These other 2 angles that we have there, and those are the special angles. Okay, and then since you understand how we go about constructing these triangles, we can go now and evaluate the trigonometric ratios for these spatial angles. Okay, so we're gonna use this table here. We have the 3 trigonometric ratios, which is sine, cos, and tan, and then we have the 3 special angles: 30 degrees, 45 degrees, and 60 degrees. Okay, so first thing first, let's determine sine of 30 degrees. What is sine? Remember SOHCAHTOA. Sine is opposite over hypotenuse side. Cosine of an angle is adjacent over hypotenuse side. The tangent of an angle is opposite over the adjacent side. Okay, and then we are focusing or are looking to find the ratio for sine 80 degrees. Here is our 80 degrees. What's the opposite side? It's side CD is the side that is opposite to the 30 degrees, which is equal to what? Is equal to 1. And what is the opposite hypotenuse side? Is the hypotenuse side is actually equal to 2. So therefore, sine of 30 degrees is gonna be what? Is gonna be 1 over 2. Is gonna be 1 over 2. Let me fill this in red. 1 over 2. And then next, let's find sine of 45 degrees. So you see, since both of these angles are equal to 45 degrees, we can use any. Okay, we can use any. So let's take this one. We have this 45 degrees, which is opposite to this side, which is equal to 1, and the hypotenuse side is root 2. So therefore, sine of 45 degrees is going to be 1 over square root 2. Okay, and then next, let's do cos of sine 60 degrees. Sine of 60 degrees here. Okay, so sine is opposite over the hypotenuse side. So this is the side now that is opposite to 60 degrees, which is root 3 over the hypotenuse side, which is 2, which is equal to 2. Therefore, sine of 60 is going to be root 3 over 2. Root 3 over 2. And then next, let's do cosine now. Let's do cosine, and let's find the ratios for the cosine of the special angles. Okay, let's start with cos 30. Cos 30, and remember that cos is adjacent over hypotenuse side. Okay, so let's come here. We have this angle 30 here. Which side is adjacent or next to the angle 30? Is this side, which is root 3 over the hypotenuse side, which is 2. And let's go ahead and write that in our table. So we're gonna have root 3 adjacent side over the hypotenuse side over 2. Okay, and then let's go ahead and look for cos 45. Cosine 45, we can take any angle between the two, which is in the both equal to 45. So it's 45 adjacent over hypotenuse, which side is next to the angle 45 is equal to 1 unit, and then the hypotenuse side is root 2. Therefore, cos 45 is going to be 1 over root 2. 1 over root 2. And then next, we have cos 60. Here we come to this triangle. Cos 60 adjacent side is 1, hypotenuse side is 2. So cos of 60 degrees is going to be 1 over 2. And then let's do the tangent. Lastly, let's look for the ratios. Let's determine the ratios for the special angles for the tangent now. So for the tangent function, it's opposite over adjacent. We determine the trigonometric ratios, the ratio for the tangent, by looking at the opposite side over the adjacent side. Let's start now. We start with tan 30. The tangent of 30 degrees, we said, is the opposite side, which is 1 over the adjacent side, which is root 3. Therefore, tan 30 is going to be 1 over root 3. 1 over root 3. And then next, we have tan 45. Tan 45, let's take this one again, is the opposite over adjacent. So it's 1 over 1, of which would be equal to 1. Will be equal to 1. And then next, we have tan 60. Tangent of 60 is the opposite side, root 3 over the adjacent, which is 1. Therefore, we're going to have just root 3 for tan of 60. And that is how you go about actually determining the ratios for the special angles. You see, you didn't have to use the calculator to actually determine the ratios for the special angles, hence why they are called the special angles. Okay, let's quickly do some examples on special angles now. But first thing first, let me move this part. I'll move into this page. Paste right there. Okay, this is example number 5, and then it says evaluate the following without using a calculator. So Once they tell you not to use the calculator, you just know that you're going to be dealing with what? With special angles. Okay, let's start. Sine 30, since we've already calculated the table, we're just going to be referring to the table. What is sine 30? Sine 30 is 1 over 2. 1 over 2. So we're going to have 1 over 2 plus cos squared 45. What is cos of 45? Cos 45 is 1 over root 2. 1 over root 2. So we're going to have, this is going to be 1 over root 2, put in brackets, squared. Forgot to put the equal sign there. Therefore, this is going to be equal to 1 over 2 plus, what is 1 over root 2 squared? 1 squared, remember the laws of exponent, 1 squared is going to be 1, and then root 2 squared is going to be 2. So 1 over 2 plus 1 over 2, that is equal to 1. You keep the same denominator, which is 2, and then 1 plus 1 is 2, divided by 2, it is equal to 1. It is equal to 1. Okay, and then the next one, cos 30 plus tan 60 degrees. What is cos 30? Cos 30 is root 3 over 2. Cos 30 is, this is equal to root 3 over 2 plus tan 60. Tan 60 is just root 3. It's just root 3. It's just root 3. Okay, and then once we are here, let's now simplify the fractions. We're gonna keep the same, what do you call this thing, same denominator, which is 2. That is the highest common denominator. And then we're gonna have root 3 plus 2 root 3 plus 2 root 3. I'm just simplifying now. Root 3, therefore this is equal to 3 root 3. This is equal to 3 root 3 over 2 over 2. Yes, and that will be your answer there. Okay, and then next we have cos 30 multiplied by tan 30 minus tan 45. What is cos 30? Cos 30 is root 3 over 2. Cos 30 is root 3 over 2, and multiplied by, let's put it in brackets, multiplied by, what is tan 30? Tan 30 is 1 over root 3. 1 over root 3. 1 over root 3, close brackets, minus, what is tan 45? It's just 1. It's just 1. Okay, then let's simplify. Root 3 over 2 multiplied by 1 over root 3. The root 3 and the root 3 will cancel. Therefore, we're going to be left with 1 over 2 minus 1. 1 over 2 minus 1, of which is equal to negative 1 over 2. This will be equal to negative 1 over 2. Okay, and then next, let's evaluate the following. Sine 45. What is sine 45? Sine 45 is 1 over root 2. 1 over root 2. So we're going to have 1 over root 2. 1 over root 2 multiply cos 45, of which is also 1 over root 2. 1 over root 2. 1 over root 2 divided by tan 60, which is root 3. Tan 60, which is root 3, multiplied by tan 30, which is 1 over root 3. 1 over root 3. 1 over root 3. Close bracket. Okay, and then once we are here, let's solve the numerator. 1 over root 2 multiplied by 1 over root 2, that will be just 1 over 2. 1 over 2 divided by root 3 multiplied by 1 over root 3. You know that this will cancel this, will be left with just 1. Therefore the answer is equal to 1 over 2. And there you have it. We have evaluated all of these expressions without using a calculator, but just using the special angles. Okay, let's go ahead and do the other example, second part of the example, which is number 2. Solve for angle x without using a calculator. So once you are asked to solve for angle s or for any equation without using calculator, just know that you're gonna be dealing with what? You're gonna be dealing with special angles. Okay, now let's go ahead and solve this one. Let's go ahead and solve this one. I'll put it here. So first thing first, we have sine x is equal to 1 over 2. Sine x is equal to 1 over 2. Okay, so here we need to actually work backwards, so we are given the ratio, we need to find the angle, so for instance here we have to go and look for which special angle when we put it in sine will give us 1 over 2, which special angle will give us 1 over 2 for the sine of that angle. And then we come here, we actually realize that sine of 30 degrees is equal to 1 over 2. Therefore it makes the angle x to be equal to 30 degrees, because it's sine of 30 degrees that gives us 1 over 2. Okay, and then next we have cos x is equal to 1 over 2. So the ratio of 1 over 2, let's go and see it belongs to which special angle. We're looking at cos. Where do we find 1 over 2? Cos here, this is where we find the ratio, which is 1 over 2 under 60 degrees. Therefore cos 60 degrees gives us 1 over 2. Therefore that x there is what now? Therefore x is equal to 60 degrees. X is equal to 60 degrees. So you see, we are now working backwards. Okay, and then for number C, we have root 3 tan x minus 1 is equal to 0. So when you see this, you don't panic. Don't panic. You just simplify it, until you are left with tan x on one side. You just have to simplify this before you start solving. So root 3 multiplied by tan x, only x is the angle there. Don't be fooled by that minus 1. Let's take the minus 1 to the other side. This is going to be equal to 1, and then we divide by root 3 on both sides. And then we will be left with tan x is equal to 1 over root 3. Tan x is equal to 1 over root 3. And then next, what do? We go to our special angles, and we look for the angle that gives us the ratio of 1 over root 3 when applied to tan. So tan of 30 degrees gives us the ratio of 1 over root 3. That makes x to be now what? X to be 30 degrees. Let me shift this. Okay, and then next we have sine 2x is equal to 0.5 is equal to 0.5. What is 0.5? 0.5 is actually 1 over 2. 0.5 is actually 1 over 2, and that 2x combined is the angle, so in this case, sine of the angle, let's say 2x was beta or theta, sine of theta is equal to 0.5, which is 1 over 2. 0.5 is 1 over 2. Maybe for you to understand, let me actually write it in the way that you will see. Sine 2x, put this in brackets, is equal to 1 over 2, so it is this angle here combined that gives us the ratio of 1 over 2, which means it is that angle 2x, of which is equal to what is the special angle that gives us 1 over 2. We have already dealt with it here, is what is 30 degrees, but let's come here. Sine of 30 degrees is what gives us the ratio of 1 over 2. So we know that 2x, that angle there, it is 2x is equal to 30 degrees, and then we solve for x. X is actually equal to 15 degrees in order for this equation to be satisfied, so as we know that if you apply this 15 degrees, we're gonna say sine 2 multiplied by 15. What is 2 multiplied by 15? That is 30, so sine 30 is what will give us 1 over 2 or 0.5, so just be careful with such questions. Then once again here, what do we have? We have cos 3x minus 15 degrees is equal to 0.5. What is 0.5? 0.5 is 1 over 2. Let's quickly write this in a manner that you are used to. 3x minus 15 degrees is equal to 1 over 2, is equal to 1 over 2. Okay, and then here you don't just take x, you don't just go ahead and see what's okay. We have the ratio of 1 over 2, and then that means x is we're gonna look at the special angle, of course, which gives us a ratio of 1 over 2. Yes, we're gonna do that, but you must always be careful that all of this angle here is equal to the special angle, not just x, so which special angles give us 1 over 2 with the cos trigonometric ratio 1 over 2 is 60 degrees. Therefore all of this here is 60 degrees. In other words, this 3x minus 3x minus 15 degrees is equal to 60 degrees, is equal to 60 degrees. Okay, and then once we are here, we simply solve for x. 60 degrees, 15 on the other side, we're gonna add, and then we're gonna divide by 3 on both sides. Therefore x is equal to, what is 60 plus 15? That is gonna be 75 divided by 3. This is gonna be 25. This is gonna be 25, and that is your final answer. That is your final answer. Final answer. And then next, let's do number F. We have 3 tan x is equal to root 3. Let's start by simplifying this so that we only have 10x on one side. So we're gonna have 10x is equal to root 3 over 3. Root 3 over 3. Okay, so we have now root 3 over 3. Let's come here. So you see something, but we don't have root 3 over 3 here. That is when we now have to go back to the set, sets. You remember sets and exponents. Set and exponent. With the sets and exponent, what are we given there? We're given root 3 over 3. root 3 over 3. Okay. So root 3 over 3 is actually root 3 over 3 is actually equal to 1 over root 3 is equal to 1 over root 3. Okay, 1 over root 3. I want to do a quick proof for you for the what you call this thing, sets and exponents. So if you have let's say root a over a, and then you multiply by root a over root a over root a. Do we agree that root a over root a is actually equal to 1? Root a, this part is equal to 1, so root a over root a divided by root a is equal to 1. So we are multiplying by 1, so this doesn't change the expression that we have here, which is root a over a, because we are just multiplying by 1. Okay, and then we come here, what are we gonna have then now? What is root a multiplied by root a? This is gonna be root a is just gonna be a, but let me remind you how we get there. We're gonna have 1 root multiplied by a, on the denominator. What are we gonna have? We're gonna have a multiplied by root a, and this is gonna be equal to, what is a multiplied by a? Is a squared under the square root over a root a over a root a. Square root a squared under the square root. The square roots will cancel the square there, or the exponent. Therefore we're gonna be left with a over a root a, and then the a will cancel the a. Then we're gonna be left with what? We're gonna be left with 1 over root a. 1 over root a. You now see that 1 over root a is in fact equal to root a over a, so if we agree on that, then we can also say that root 3 over 3 is equal to what? 1 over root 3, so you can calculate that by just following the steps that I laid down for you there, so these are the laws of exponents and sets. Okay, I just wanted to clarify that for you, because I know some of you want to see root 3 over 3, but on the special angles we don't have that. You just have to know that root 3 over 3 is equal to 1 over root 3. So 1 over root 3 belongs to what? It belongs to tan 30. Tan 30 is the trigonometric ratio that gives us the ratio of 1 over root 3. So tan 30. Okay, I don't think we need this, or maybe let me not remove it. Tan 30, therefore x is equal to 30 degrees. X is equal to 30 degrees. And there you have it. That is the example on the special angles. Okay, and then next we have the angles of elevation and depression. The angles of elevation and depression. So a simple way to illustrate what are we talking about when we refer to angles of elevation and depression is by the following. Look at the following diagram. So we have that angle theta there, and then that angle theta is the angle of elevation of B from A, Okay, what does that mean? It's essentially the angle that tells us how far B is raised or is elevated above A, above point A, so that is basically the angle of elevation. And then the opposite of the angle of elevation is what you call the angle of depression, so and it's represented by alpha in that case if you look at diagram number 2. And what does that angle of depression tells us? So alpha is the angle of depression of A from B. Okay, so it basically tells us how far below is point A from point B, or how far or how much is A depressed from point B, from point B. So those are the angles of depression and elevation. I think one thing to mention here is that the angle of, for a given diagram, the angle of depression or angle of elevation is equal to the angle of elevation is equal to the angle of depression. And the reason is that they are alternating angles. Let me put in bracket alternating angles. So let's say we were to come to this initial sketch here that we have. If we have an angle of depression here, just put, let's say we call it beta, angle beta that we just drew there, angle beta will be equal to angle theta because they are alternating angles. So that is what is meant by the statement I just made there, that angle of elevation is equal to the angle of depression because they are alternating angles. Okay, so let's quickly do this example regarding the angles of depressions and the angle of elevations. Okay, so the Cape Town cable car takes tourists to the top of the Table Mountain. The cable is 1.2 kilometers in length and makes an angle of 40 degrees and makes an angle of 40 degrees with the ground. What is that angle 40 degrees called? That is the angle of elevation. And then we are asked to calculate the height of the Table Mountain. So the height, which is h. Okay, what do we have here? We have angle 40 degrees. We have h, which is the opposite side, the side that is facing the angle of concern, which is 40 degrees. And then we have the side that is facing the 90 degrees angle, which is 1.2 kilometers, or the hypotenuse side. So if you remember, SOHCAHTOA, opposite over hypotenuse, which trigonometric ratio we're going to use is the sine trigonometric ratio. So for A we're going to use sine, let's just say sine of theta is equal to opposite over hypotenuse. But we know that here we are dealing with what is the angle of elevation there. The angle is 40 degrees. What is the opposite side? Is h, the one that we are looking for. And what is the hypotenuse side? Is 1.2 kilometers. And then let's make h the subject. So we're going to have 1.2 kilometers multiplied by sine of 40 degrees. And then you punch this in your calculator. In order to find the height is gonna be 0.77 kilometers. 0.77 kilometers. 0.77 kilometers. Okay, so the purpose of this example is just to show you how this what you are learning can be utilized in a real life or real world example, or real life example, so yeah, once you guys draw and you become engineers, you're gonna be using what you are learning here. Okay, so that was example number 6. Okay, next we're gonna be dealing with angles on a Cartesian plane. Angles on the Cartesian plane. Okay, so we have the Cartesian plane as it is drawn there. Okay, so far we have been dealing with angles on a triangle, but we can also look at the angles on a Cartesian plane and use trigonometric ratios to sort of determine, maybe to calculate the angles on a Cartesian plane, or to solve for the length, the length of the opposite or the adjacent side. Okay, so we have the Cartesian plane that you have there. So first thing first, we have the arm from the origin point there. This is what we call the terminal arm, what I'm just drawing here, and that R is the terminal arm. It gives us the radius of the circle. So in the case of the triangles, it is actually the hypotenuse side. If you want to look at it that way. And then next, what do we have? We have point R. So point R is any point that lies on the circumference of the circle, that you see there. That is our point R. Point R will have two coordinates, which is x and y, and those coordinates, they stand for the sides, of the triangle. They stand for the side. So x will always be the adjacent side, and then you have y, which is the opposite side. Is the side that is opposite to the angle, and the angle theta is measured. The angle theta that you see there is always going to be measured from the positive x-axis to the radius OR, or to the terminal arm, which is R. Okay, and then as I've told you that your x basically stands for the adjacent side, and the y is for the opposite side, and then you have R for the terminal arm is your hypotenuse side. So using the Cartesian plane, this is how you're gonna represent your trigonometric ratios. Sine of theta is equal to y over R. Opposite over, this is the side that is opposite to the angle theta, is represented by the y coordinate. Hence why we have y over R. The R is the length of the arm, OR is the length of the terminal arm, OR, and it is our hypotenuse side. And then next, what do we have? We have cos x. I told you that x, you can look at it as if it stands for the adjacent side, because that is the side that is next to our angle theta. So cos of theta is equal to x over R, and then tan theta, you have y over x, opposite over adjacent. So that is how we work around with the angles on the Cartesian plane. Okay, so there are a few things that you need to know about the angles on the Cartesian plane. First thing first, the Cartesian plane is divided, as you already know, into 4 quadrants. It has 4 quadrants. The first quadrant is that one between 0 and 90 degrees. The first quadrant is between 0 and 90 degrees, and then we know that there on the first quadrant, both the x values and the y values are positive. So x is positive and also y is positive. Where? On the first quadrant. On the second quadrant, we know that x values are negative and y values are what? Are positive. And then on the third quadrant, we know that x values are negative and y values are negative. And then on the fourth quadrant, which is between 270 degrees and 60 degrees, the x values are positive and the y values are negative. Okay, what does it tell you? It tells us that if you are, let's say, okay, let me come here. Yeah, that tells us if you are looking for a trigonometric ratio of an angle that is found between 0 and 90 degrees. That is found between 0 and 90 degrees. If our angle theta is there and you are looking for sine of that angle theta, you're gonna have what? Remember that r, the terminal arm, r is always positive. R is always positive. So if you are looking for a trigonometric ratio, any trigonometric ratio on the first quadrant, all the ratios will be positive. All ratios are positive on the first quadrant. That is what is meant by that all plus. All ratios are positive in the first quadrant, because let's say you are looking for the ratio of sine theta. You're gonna have sine theta is equal to y over r. Y is positive and r is positive. And if you are looking for cos theta, what are you gonna have? You're gonna have cos of x over r. X is positive and r is positive, so you have a positive ratio. And then next, if you were to look for the tangent of theta there in the first quadrant, you're gonna have opposite over adjacent, y over x, so it's also positive. Okay, but let's move forward. We know that in the second quadrant now, in the second quadrant between 90, let me quickly actually write this. This is 90 degrees, 0 degrees is 180, 270 degrees, and 360 degrees. Okay, and then in the second quadrant, we know that x is negative and y is positive. So it is only gonna be sine. As you can see there, what's the reason? It's only gonna be sine of theta that will be positive. That is what is meant by that sine theta plus. Only the ratios of sine theta are gonna be positive on the second quadrant. Let's quickly show what we are talking about. Sine theta is equal to what? Is equal to y. Y is positive over y over r. So it's equal to positive y over r. Therefore, we're going to have a positive ratio. Let's look at cos. Cos is what? Cos of theta is x over r. But our x in the second quadrant is negative. Therefore, we're going to have negative x over r. Therefore, we're going to have a negative ratio. Let's go ahead and do tan of theta. Tan theta is what? Is opposite over adjacent. It's y over x. So y over negative x. Therefore, we're going to have a what? A negative ratio. So only sine is positive in the second quadrant. In the third quadrant, only tan is positive. Only tan is positive on the third quadrant. Only tan is positive. Let's quickly show what we're talking about. Let's start by looking. Okay, and then the angle will be this angle. Actually, I forgot to include something. This will be our angle theta now when we are looking at the second quadrant. For the what you call this thing, this is our angle theta. Third quadrant. Okay, doesn't wanna be smooth. One last change. Okay. Okay, that is our angle theta. Now at the third quadrant, we said only the trigonometric ratio of tan is going to be positive. What is our sine theta in the third quadrant? Sine theta is y over r, so it's negative y over r. Therefore, we're going to have a negative trig ratio. We're going to have a negative ratio for cos theta. Cos theta is going to be what? It's going to be negative x over r. Once again, we have a negative ratio. But for tan theta, we're going to have tan theta is equal to negative opposite negative y over negative x. The negative and the negative will become positive. Therefore, we're going to have a positive ratio. And then in the fourth quadrant, as you should now be able to see where we are going with this, cos theta positive, cos theta plus sine. Cos theta plus sine, what does that tell us? It tells us that only in the fourth quadrant, only the trigonometric ratio of cos will be positive in the fourth quadrant. Therefore, let's quickly calculate sine theta. Sine theta is equal to y, but y is negative in the fourth quadrant, so we're going to have a negative y over r, negative ratio. Cos theta is what? Cos theta is x over r. X is positive over r, therefore it's positive. And then for tan theta is y over r. We have a negative y over positive x, negative ratio. Okay, so what we are seeing here is actually what we call the cast method. The cast method. So always remember that when you use the cast method, we start from the fourth quadrant, first quadrant, second quadrant, third quadrant. Okay, and you focus on only this term C A S T, and that is your cast method. That is your cast method. Cast method. Just remind yourself with that weight if you happen to forget which ratio is positive in which quadrant, but yeah, that is how you actually determine that when you are working with the angles on a Cartesian plane. Okay, let's do an example to actually show what we are talking about. Let's see. Okay, I have a page. Let me take this, cut to this page here, to this page. Okay, and there we have it. Example number 7. So for example number 7, in which quadrant does the terminal arm of the angle theta lie if sine theta is greater than 0? So sine theta is positive. We know that sine theta is positive in which? First quadrant and second quadrant. Sine theta is positive because in first quadrant all they are positive, and also here sine theta is where it's positive. Okay, so let me do it like this. And cos theta is positive. Let's quickly draw our sketch. Suppose we use a black one. Just quickly draw our Cartesian plane. We are told that in which quadrant does the terminal arm of the angle theta lie if both sine theta and cos theta are greater than 0? So they are both positive. Where are they? All the trigonometric ratios positive, so they are all positive in what? In the first quadrant. So the terminal arm will be here, in the first quadrant. quadrant, because that is where they are all positive in the first quadrant. So we have cast method. In quadrant 4, only cos is positive. Quadrant 1, all of them are positive. Quadrant 2, only sine is positive. Quadrant 3, only tan is positive. Okay, and then next, this is our B. In which quadrant does the terminal arm of the angle theta lie if sine theta is negative? Sine theta is negative, or sine theta is less than 0, which is negative, and cos theta is less than 0. We know that sine theta is negative where and where. Sine theta is negative here because only tan is positive there, and sine theta is negative here because only cos is positive in quadrant 4. And then, but we are also given that condition that also cos theta has to be positive, it has to be negative, where cos theta is also negative. So we know that cos theta is negative here and is negative here. See now, there in quadrant 3 we have 2 stars, therefore this will be dead quadrant. Dead quadrant. This will be dead quadrant. Actually, I should have just copied this. Copy and paste here. Dead quadrant. So this is our A. Therefore, the terminal arm will be in the dead quadrant. Okay, let's go to number C. In which quadrant does the terminal arm of the angle lie if tan theta is negative? Let's go ahead and erase this. Tan theta is less than 0, so it's negative. Let's mark all the quadrants where tan theta is negative. We know that here only sine is positive, therefore tan theta is negative, and also here in cos, that is where tan theta is negative, and cos theta is negative. We know that cos theta is negative here in this quadrant is negative, and also negative here because only sine is positive in the second quadrant. Therefore, the terminal arm will lie on the second quadrant. On the second quadrant. Okay, that is how you go about answering that. Let's go ahead and do number 2 of this example. So for number 2, we are told that if sine theta is equal to 3/5 and theta is greater or equal to 0 but less or equal to 90 degrees, that condition, determined by means of a diagram cos squared theta and 2 tan theta. So first thing first, we need to construct our diagram with the information that we have been given there. What have we been told? We were told that sine of this theta, is what? Is 3/5. And theta, we are told that the angle theta lies between 0 and 90 degrees. So already that tells us that we are working with the first quadrant. So we have 0, 90 degrees, 180 degrees, 270 degrees, and then that's your 360 there. So already we know that our terminal arm will be in the first quadrant because we are working with that theta is between 0 and 90 degrees. So this is our theta there. And then let's construct our triangle like this. We are given that sine theta is equal to 3 over 5. Which side are we looking at? When we are working with the sine trigonometric ratio, we are looking at the opposite side and the hypotenuse side. Therefore, the opposite here, which is gonna be 3, and the hypotenuse is gonna be 5. We can calculate the adjacent by using the what you call this thing, Pythagoras theorem. So the adjacent side there, I'm just gonna say adjacent squared is equal to hypotenuse squared minus the opposite side squared. Therefore, adjacent side is gonna be 5 squared is what? Is 25 minus 3 squared is 9 minus 9. So adjacent squared. (25 minus 9 is 16. We introduce the square roots on both sides. Therefore, adjacent side is going to be 25 minus 9. We said it's 16. Square root of 16 is what? Is 4. The adjacent side is 4. Or the value of x, if you like. You can just say it's the value of x. The value of x there. Okay. So once we are here, we basically have everything. We can now determine cos squared theta. Since we have completed our diagram, our A, we are looking for number A, cos squared theta. Cos squared theta is going to be equal to, what is cos theta? Cos theta is adjacent over hypotenuse. So cos theta is going to be 4 over 5. All of this squared. Therefore, we're going to have, what is 4 squared? Is 16 over 5 squared, which is 25. Which is 25. And there you have it. And then next, for number B, we have 2 tan theta. 2 tan theta. So we keep the 2, open the bracket. What is the ratio of tan theta? Tan theta is opposite over adjacent. What is the side opposite to the angle theta there? Is what? Is 3 over 4. Therefore, this is equal to 2 multiplied by 3 over 4. So it's gonna be 3 over 2. 3 over 2. And that is your answer there. So that is how you solve for these. Yeah, that is how you basically evaluate these expressions by using a diagram. Let's do another example. Let me quickly add the page for this one. Yeah. Okay. And then for number 3, we are told that if tan theta is equal to 5 over 12, what is tan theta? Tan theta, always remember that tan theta is what? Opposite over adjacent. So it's 5 over 12. So already, what does that tell us? Tan theta is positive. But tan theta is positive in which quadrants? Tan theta is positive in quadrant 1 and 3. Put the stars, and then sine theta is greater than 0. So we are also told that sine theta is greater than 0, which means sine theta, the ratios will be positive. And sine theta is positive in which quadrants? Is positive here and here in quadrant 1 and 2. And then, as you can see, that we have 2 stars in which quadrant? In quadrant 1. What does that tell us? It tells us that our arm will be in quadrant 1. Let's come here now and construct our arm. in quadrant 1. In quadrant 1, that is where we're gonna have the terminal arm. Okay, so quadrant 1, that is where we have the terminal arm, and then we are given that ratio of tan theta is 5/12, so the opposite side, which is our y, is 5, adjacent is 12, and this is our angle theta here. We can calculate the hypotenuse side using the Pythagoras theorem. Hypotenuse side squared is gonna be 12 squared plus 5 squared. Therefore, the hypotenuse side is gonna be, what is 12 squared? 12 squared is 144 plus 5 squared is gonna be 169. We introduce the square roots on both sides. Therefore, the hypotenuse side is gonna be 13. So 12 squared plus 5 squared is 13. Yes. Okay. So, and then once we have this, we can go ahead and evaluate the expressions that we are given there. We can go ahead. So we have to evaluate 13 cos theta. 13 cos theta. We keep the 13. What is cosine of theta? Cosine of theta is adjacent side over hypotenuse, so it's 12 over 13. 12 over 13. So we're gonna have 12 over 13. So 13 multiplied by 12 over 13 is basically equal to 12. That is how you evaluate that first expression. Secondly, we have cos squared theta plus sine squared theta, which is a cos squared theta plus sine squared theta. Okay, before we evaluate this one, I want you to also notice something here. Remember that identity that I told you a little bit about, the questions we did on the previous lesson, where we said cos squared 22, I would like to believe 22 plus sine squared 22, and we also did another 2 examples with the same angles, and we always found that for this situation here, the answer will always be equal to 1. Will always be equal to 1 if you have the same angles. But let's go ahead and evaluate this and see what do we get. So what is cos theta? Cos theta is 12 over 13 squared plus, what is sine theta? The opposite side over hypotenuse is 5 over 13. 5 over 13 squared. Okay. Then once we are here, basically we have to now simplify. We're gonna have 12 squared is 144 over 13 squared. Remember laws of exponent. 13 squared is 169 plus 5 squared is 25 over 13 squared is 169. We add the ratios, we add the fractions, we keep the same denominator, which is 169. 144 plus 25, 144 plus 25 is 169 over 169. This is equal to 1. So once again, this identity comes back, but you will learn more about it when you get to grade 11. Okay, and then that is how you basically go about evaluating trigonometric expressions using angles that lies on a Cartesian plane. 0 degrees, 90 degrees, 180 degrees, 270, all the way to 360 degrees. Okay, and then for number 6, let's look at something called the reciprocals. So we have reciprocals of trigonometric ratios. We have reciprocals of trigonometric ratio. But first thing first, what is a reciprocal? So a reciprocal of a number is a number which, when multiplied by the original number, gives an answer of 1. So for example, if you have the number 8, and you multiply it by 1 over 8, what you will get? You will get 1. Therefore 1 over 8 is the reciprocal of what? Of the number 8. So another example, we can just say a multiplied by 1 over a is equal to 1. Therefore, what does that mean? It means that 1 over a is the reciprocal of what? Is the reciprocal of a, because when we multiply it by a, it gives us 1. So basically those are the reciprocals. So a reciprocal of a number is a number which, when multiplied by the original number, it gives the answer of 1. Okay, so also the trigonometric ratios, they have reciprocals, so these are the functions, reciprocal functions of the trigonometric ratio. We have the cosecant function. First one, cosecant function, or sometimes it's just called cosec, and it is the reciprocal of sine theta. So cosec theta is the reciprocal of sine theta, which means that cosec theta is basically equal to 1 over sine theta. As you see here, it's just 1 over sine theta. And then if we evaluate that, so instead, we know that normally when we deal with sine theta, we deal with opposite over hypotenuse. But for the reciprocal, we have hypotenuse side over the opposite side. So it's the other way. The numerator becomes the denominator, and the denominator becomes the numerator. That is the reciprocal. And then we have another reciprocal, which is the secant function, or sometimes just called sec theta. And sec theta is the reciprocal of what? Is the reciprocal of cos theta. So when we write it, sec theta is equal to 1 over cos theta, and then the ratio is going to be hypotenuse over the adjacent side, because remember that the ratio for cos theta is what? Is adjacent over hypotenuse. Therefore, for the reciprocal, it's going to be the other way. Numerator becomes denominator, denominator becomes numerator. So that is the ratio for the second function. And then lastly, we have the reciprocal of tan theta, and that one is called the cotangent function. It is called the cotangent function, and then, or abbreviated as cot theta. So cot theta is the reciprocal of tan theta. We know that means cot theta is equal to 1 over tan theta, and then the ratio for the cotangent function is going to be adjacent side over the opposite side. It's the reciprocal, the opposite of what we used to. Okay. And then next, let's do examples of the what you call this thing, of the reciprocal functions. So we have example number 8 there. Let me trade some space here. Example number 8. So refer to the diagram and answer the questions that follow. Okay, determine the following. So we have the diagram here with points A, C, and B. So determine the following. Sec of angle A. Remember that sec is the reciprocal of which function? Is the reciprocal of cosine function. So we are looking at the adjacent over the hypotenuse. So sec but for sec is the reciprocal. So sec A is gonna be, this is the A we are referring to, the angle A. The adjacent is 3 and the hypotenuse is 5, so it's gonna be 5 over 3. You reverse it, and then cos is the reciprocal of tan. And what is tan A? Tan A is gonna be opposite over adjacent, is gonna be 4 over 3. Therefore cot A is gonna be 3 over 4. Cot is adjacent over opposite. And then we have cosec A. Cosec is the reciprocal of sine theta, so cosec A is hypotenuse over opposite side, so we're gonna have 5 over 4. That is the reciprocal of sine A. Okay, and then next we are looking at this angle C, and we have to determine cot C. Cot C is gonna be adjacent over opposite side, so this is gonna be equal to reciprocal of tan. Remember, so it's adjacent, it's gonna be 4 over 3, because what is the side adjacent to C is 4 and the opposite side is 3, so it's the reciprocal of tan. And then for number 5, cosec C. Remember that cosec is the reciprocal of sine, so what is the reciprocal of sine is gonna be hypotenuse side over the opposite side, so we're gonna have 5 over 3. So we are just reversing what we are normally doing. And then sec C is the reciprocal of cos. Sec is the reciprocal of cos, so it's gonna be 5 over 4. And that is how you actually evaluate the reciprocals. And then I think that marks the end of today's lesson. I will meet you guys again on the lesson on functions, on trigonometric functions, and until we meet again, I wish you guys good luck and good studying.